Just before we begin, I'm recording this after the fact. I've already filmed the video and I've just looked back at the footage, and the recording of me is absolutely fine, but the recording of my screen is done more in pictures than video form, which you'll see. So rather than you being able to see every input that I make, it sort of refreshes itself every 30 seconds or so. Um, Hopefully you'll sort of keep up with what I'm doing. You might have to listen to my explanation just a little bit more than look at what I'm doing today, because stuff will just appear out of nowhere. So I'll do sort of 30 seconds of writing and work, and then bam, it'll just be there. I've absolutely no idea why it's happening, to tell you the truth. There's no way that I know until I'm finished, and it was the best part of a 20-minute video today. So I recorded it. 20 minutes later, found out it hadn't done it properly. I'm not going to go and do that again. I'm going to just try and find a fix for tomorrow. So just work with it the best that you can today. I know it might not be ideal, but I'll see what I can do about it. Okay? Questions are a little bit different today, taken from the same place, but they're asking something different of us. As you can see, they would like us to set out and solve these questions as long multiplication. Okay, which means that our mental methods are off the table now. We have to follow the formal method. Okay, so we'll have a go at the first. Well, I'll leave them up just for a second so you can have a go at yourself if you want to, by pausing the video. If not, you want to have a go along with me, that's fine. I'll make a start. So the first one is 497 times 5. Now it's really important that when you're using the long multiplication method, you set it out correctly and you set it out neatly, just so that you're not going to make any silly errors based on how you've laid the question out. You want to make sure that you reduce the amount of potential errors. Okay. So for long multiplication, you work across the top number. So you start with your units, then your tens, and then your hundreds, and you multiply each of them by the bottom number. Okay. And luckily on this question, it's fairly straightforward. We've only got a one-digit number. So we're going to start by doing 7 times 5, which is 35. So underneath the line, 5 goes in the units, and the 3 tens just gets put there. Okay, I'm just going to hold it for now, because I haven't got a tens column yet to put it in. So now I'm going to do 9 times 5, but it's not 9, it's 90. Okay, but I know that it's 90, so I don't need to say it's 90, because it's going to end up in the correct column. So 9 times 5 is 45, so 90 times 5 is 450. So the 5 is going to go here, and then the 4 is going to go there. However, I'm just going to change the rubber, because the 5 isn't going to go there, because I need to put this on. Okay, so it's going to be an 8 there. Okay, so it's 45 or 450. So 5 is going to sit in the tens column, but I have the 3 tens to add on, so it's an 8. Okay, with the 4 hundreds to sort out when I get there. 4 times 5 is 20, so 400 times 5 is 2000, but I'm going to stop that now. I'm just going to stick to the units times the units. So that 4 times 5 is 20, so it's going to be a 0 here and a 2 here, but I've got that 4 to sort out, so it's going to be a 4. 0 add 4 is 4, and then the 2 there. So it's 2, 4, 8, 5. Okay. So that one, that one I talked you through the proper place value and the place value that I would be saying in my head. But from now on, I'm just going to stick to the place value in my head, if that makes sense. Otherwise, I'm going to start confusing you. The numbers will get very big. So you've got 5642 times 2. And again, nice big layout. You'll notice I'm quite a scruffy mathematician usually, but when it comes to a formal method, it has to be spot on. 2 times 2 is 4 in the units. 4 times 2 is 8, but obviously that's 80. But 6 times 2 is 12. 5 times 2 is 10. 11,284. Okay. And again, just to make sure that there's no confusion, when I've said 5 times 2, that's not 5, it's 5,000. But if I know what 5 times 2 is, then I know what 5,000 times 2 is. So all I'm doing when I'm speaking out loud and saying 5 times 2 is then letting my brain sort of fill in that next step, if that makes sense. So I'm saying 5 times 2 is 10, and then up here I'm going, well, that means it's 5,000 times 2 is 10,000. Sorry, right. 56 times 18. Now this is where it gets a little bit trickier, which sounds silly, because you've just done 5,000 times 2, and now you're doing 56 times something. But this is the mistake that a lot of you kept making this year. So we'll do 56 times 8 first of all. 6 times 8 is 48. 8, 4. 5 times 6, 40. Yep. Yep, I put 4 on, so it's 448. Okay. So I've done this 8. 56 times 8 is done. Now it's 56 times this 1. Sorry, you can't see. Can't see that, can you? This 1. But it doesn't represent 1, it represents 10. So my two choices are, I can either work through the whole question, going, oh, 6 times 10, 5 times 10, or I can keep it as a 1 in my explanation, but put a placeholder 0 here. Okay. So 6 times 1 is 6, but 6 times 10 is 60. Well, I've written 60. Okay, so by dragging that 0 down because I'm multiplying by 10, all of my answers have the correct place value without me having to do a lot of working out. Okay, so 5 times 1, this is actually 50 times 10, but because I've put that placeholder 0 here, which is what most of you are forgetting to do, because I've put that there at the beginning of the question, I can now just calculate 5 times 1 and put it in the place value column I'm working in at the moment. 5 times 1 is 5. And then if I add these together, I should have the answer if I did it right, 50. Okay. Doesn't feel right, so I'm just running it through some filters. I've always said about using your checks and trusting your instinct and things. Something just wasn't feeling right there, so I've run it through. Again, I've recalculated it, and it looks okay to me. Might still not be, but we'll see. So you've got an 8, you've got 0, carry 1008, which, yeah, spot on. Okay, so it was fine, just didn't look fine. 42 times 25. 42 times 25. 2 times 5 is 10. 4 times 5 is 20. Nope. Get rid of that. Easy mistake to make there. No, just use the rub. So because 4 times 5 is 20, what I've done there is put the one that I carried over and put 30, which isn't right. Okay, so let's put the place value back in. So you've got units, tens, hundreds. Okay, so I put 110 carried. 4 times 5 is 20, so 45. Try again. 4 times 5 is 20, so 40 times 5 must be 200. Okay, so I need a 2 there, and obviously the 100 there, but I've got that 10 to carry, so it's 210. Okay, so that was a really, really easy mistake to make, but 42 times 5 can't be 30. Okay, so the logic, as I've just said a minute ago, the logic kicks in and goes, no, you've made a really silly mistake there. Okay, can you place all the 0 down? 2 times 4, so 20 times 2 times 20 is 40. 800. Okay, 840. Add them together. 1050 should be 0, 5, 0, 1. Yeah, 1050. Okay, 68 times 34. 8 times 4 is 32. 6 times 4 is 240, 270. Lost my pen. 6, 12, 18, 24, 240, 270. Okay, and then down. 8 times 3 is 24. Put that down there to carry. 6 times 3 is 18, 20. Ooh. Okay, so I was working that one out without telling you really, wasn't I? 8 times 3 is 24, or 8 times 30 is 240, so you've got the 40 there, 200 in weight in here. 60 times 30 is 1,800. Okay, we've got the 200 to add on, so that means it's 2,000. So the 0 goes there and the 2 goes there. Okay, now I'm just going to put this little bit out here just so I can do my adding up. 2, 3, 2, 2, 3, 1, 2. Perfect. Right, much bigger numbers now. Much bigger, but the logic stays the same. If you can do number 5, then you can do number 6 because the rules aren't changing. What would be a little bit more complicated is if this was 262 or something, because then I've got another step to do. But it's the same step I'm doing, just with more calculating. So let's just clear the ink. But because it's a bigger number now, the layout's going to be really key. So I'm just going to zoom that out and make sure it's beautifully set out. I know it's very straightforward, but I probably should have said you have to make sure everything's in the correct place value column as well. It's no use putting this 2 here because it's not representing 2000s, it represents 2 tens, 20. Okay, so 6 times 6 is 36. Carry the 3. 3 times 6 is 18. Add that on is 21. Obviously 210. Okay, I'm just going to keep flip-flopping between, but to me it's 21. 5 times 6 is 30. Add the 2 on, it's 32. 4 times 6 is 24. Add that on is 27. Okay, so you've got an answer of 27,216. Because it's a bigger number, you just run it through and think whether that sounds reasonable. So you've got 4,000 times 6. 4, 8, 20, yeah, it does. That sounds reasonable. It's in the right ballpark, isn't it? So you know you're on the right lines. Pull your 0 down, because this 2 doesn't represent 2, it represents 20, so you need everything multiplied by 10. 6 times 2 is 12. 3 times 2 is 6. 7 because I had the 100 to add on. 5 times 2 is 10, but obviously it's not 5, it's 500 times 2, so it's 1,000. So this is 1,000. Oh no, I've got it. I've said 500 times 2, didn't I? It's 500 times 20, which would be 10,000. So you have got 0 in the thousands column and 1 in the 10,000s. Okay. Whew. Good save there. 4,000 times 2 is 8,000. Yeah, got it. Oh, I'm getting confused with the 10,000. 4,000 times 2 is 8,000, but this is the 10,000 column. So 4,000 times 20 would be 80,000. Put that on, would be 90,000. Hopefully there you can see how you are still doing the same step from question 5, but it is trickier. But it's only tricky because you've got more place value columns to lose track of, which is exactly what I've done in that question. I've managed to lose track of them, but I'm not actually doing any new skills. I know my place value columns, and I know to bring this 0 down because I'm multiplying by 20, not 2. But it still causes issues. So add these up, and hopefully, fingers crossed on this one, I've got the answer. 6, 3, 9, 7. So it's 117,936. Perfect. Whew, saved it. Good. Okay. Now, sorry. For that question, it might have felt like I wasn't very confident with what I was doing. And I won't lie to you, I wasn't very confident. It's not my strongest method to use this. However, all the way through when I'm questioning myself, I wouldn't see that as a sign of weakness. I would see that as a sign of strength because I'm questioning everything I'm doing. I am not just calculating and writing. I'm calculating and going, no, hold on. That can't be right. Oh, I've missed this step. Oh, of course it does make sense now. And that's a much better mathematician than the mathematician who just goes, oh, well, I've done 8 add 2 and it's 10, so I'm just going to write 10. And not thinking, hold on. I can't put 10 though, can I? So what have I got wrong? Okay. So while it might look like I was jostling about all over the place, which I was, because it is not the easiest method for me, still got the correct answer in the end because I was questioning everything I was doing. 3, 5, 90 times 64. And again, nice big, clear layout. Sorry. So 0 times 4 is... Oh, pen's gone. 0 times 4 is 0. 0 times anything is 0. 9t. But 9 times 4 is 36, so 360. So 5 times 4 is 20. 3. 2. 3 times 4 is 12, but it's 3,000, so it's 12,000. Add the 2 on, it's 14,000. So 14,360 at the moment. Okay. Pull that down. 0 times 6 is 0. 9 times 6 is 54. 5 times 6 is 30. Yeah, 30. Oh, I haven't done that very well, have I? I'm going to change that before it causes me a problem. Okay, 30, but I'm going to add that on, carry over. And then 3 times 6 is 18. But it's 3,000 times 60, so it's 18. But I've got the 3 to add on, so it's 250. Okay. Right. Okay. So you've got 0, 6, 7, 9, 229,760. Perfect. Lovely. Okay. The more practice you get at those, the better. The reason I'm a little bit rusty as well is because I haven't used that method in a very long time. I've had to refresh myself on the layout just before I've done this video, because it isn't one that I use naturally. So if you've struggled as well, that's fair enough. It might be worth, if you did find it difficult today, having a go at a few more after the end of the video, just to refresh your brains on it. We've done a lot of it this year, and we did get to the point where we'd solved that problem of let's do 24 times 24, blah, 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 of pulling that 0 down, because you're multiplying by multiple of 10. We did get to the point where we'd solved that, but it might have disappeared again. Okay. So as usual, I will leave you for a little bit. I'll put a challenge question up on the board. Haven't got a board. One day I'll learn. I'll put a challenge question up on the screen for you to have a look at. Then I'll come back in all my glory and I will have a go at it myself. Show you how you might have worked it out. Normally they're sort of reasoning-y problems, so my method of reasoning might have been different to yours. It's not a problem. But if you were struggling with how to do it, you can see, and then I'll give you the answer as well. Okay, which I'm sure you know by now anyway. So I will disappear, question will come up, pause the video if you want to, and then I will return and show you how to do it. Okay. So you've had a look at the question by now, and hopefully you've had a go yourself. So we're going to have a look at it together. It's a bit of a problem-solving one again. Just using your knowledge of other areas of maths, but also your place value knowledge. So Timmy is thinking of a decimal number with 3 decimal places. Use the following clues to find Timmy's number. Okay, so what I'm going to do first of all is sketch out a number for 3 decimal places. Okay, so that I can start filling them in. And obviously you've got your units, and then you've got your tenths, your hundredths, and your thousands. Okay. The digit in the thousandths column is equal to 2 squared. Well, I know what 2 squared is. It means 2 times 2 equals 4. So that must be a 4. The hundredths digit is a prime number between 6 and 10. Okay. So a prime number is a number that is only divisible by 1 and itself. So if it's between 6 and 10, you've got 7, 8, and 9. Okay. 7 is a prime number because it's not divisible by anything but 1 in itself. 8 is divisible by 2, and 9 is divisible by 3, so it must be 7. The ones digit is the smallest possible odd digit, well, that's 1. The digit in the tenths column is a quarter of 12, which means 12 divided by 4, or 12 split into 4 equal groups, which is 3. Okay, let's check I've got that. Yeah, so it's 1.374. Okay, not a particularly complicated one today. It's just a case of following the steps through. And again, laying it out like that, you can see the working out that I needed, but means that I'm not trying to keep everything in my head. Everything that I record goes on the sheet straight away. Okay. Excuse me. So I will leave you there, and I will see you tomorrow. Apologies for the fact that my screen wasn't keeping up with the video recording. I had the problem the other day and recorded the video again, but this was a really long video, and I thought you can probably work around it. I'll have a look at trying to fix it the best way that I can, but I'm not making any promises. If it doesn't work, I will find some compromise so that you're not just seeing what I'm doing sort of 30 seconds after the fact. Okay, so hope you have a good day, and I will see you tomorrow.